Welcome to the DIY Honda Garage channel. The DTC B2029 indicates a malfunction with the left power sliding door remote control switch on 2011 to 2017 Honda Odyssey models. This error code specifically signifies an issue with the signal received from the left power sliding door remote control switch. The left power sliding door remote control switch is responsible for facilitating the opening and closing of the left sliding door from a distance, providing convenience for the driver and passengers. Its location is typically on the driver's side or integrated within the left power sliding door control unit. When this system fails, it can lead to difficulties in accessing the vehicle, especially in tight spaces. Understanding the components involved and the nature of the error is essential for accurate diagnosis and repair. The subsequent slides will delve into specific details regarding the components affected, possible causes, symptoms, and a step-by-step troubleshooting guide. DTC B2029 pertains to an error involving the left power sliding door remote control switch, which plays a vital role in the seamless operation of the vehicle's sliding door. This switch allows drivers to open or close the left sliding door without physical contact, enhancing convenience and accessibility. Its operation relies on signals transmitted to the left power sliding door control unit, which governs the door's mechanics. The left power sliding door remote control switch is typically found on the driver's side door panel, making it easily accessible for the driver. When this system encounters issues, it can disrupt the functionality of the sliding door, making it difficult to open or close using the remote control. Recognizing the fundamental roles of these components is critical in diagnosing the problem effectively. When diagnosing DTC B2029, several potential causes may emerge. One primary concern is a short to ground in the wiring, which can disrupt the signal path essential for proper operation. This means that the electrical current intended for the switch could be incorrectly channeled, leading to malfunctions. Another potential issue is a faulty control unit, which manages the signals received from the remote control assembly. If this unit is compromised, it may fail to process the information required to operate the door. Additionally, a defective remote control assembly can contribute to the error, wherein the switch itself may not be transmitting the required signals effectively. Each of these causes can lead to the symptom described in the DTC B2029, making it essential to methodically investigate each avenue during troubleshooting. The symptoms associated with DTC B2029 are primarily characterized by the inoperability of the left sliding door. Owners may notice that the door does not respond to commands from the remote control, indicating a failure in the system. Additionally, the presence of the specific error code B2029 during diagnostic scans further suggests a significant issue that needs addressing. Remote control dysfunction may manifest as either intermittent or complete failure, complicating access to the vehicle. These symptoms can create inconvenience for users, particularly in situations requiring quick access to the interior of the vehicle. Understanding these symptoms is critical as they guide technicians in identifying the root causes accurately and expediting repairs. The initial step in troubleshooting DTC B2029 involves clearing any existing diagnostic trouble codes, DTCs, using the Honda Diagnostic System HDS. The HDS is a specialized tool designed for diagnosing and repairing Honda vehicles effectively. Clearing the DTCs resets the system, allowing technicians to assess if the B2029 code reappears after basic functionality checks. This step is essential as it helps to eliminate any historic codes that may influence the current diagnosis. enabling a clearer understanding of real-time data from the vehicle's network. After clearing the codes, it sets a clean slate for an accurate diagnosis and is thus crucial for troubleshooting to prevent misinterpretations in subsequent steps. Following the clearing of DTCs, the next troubleshooting step requires the technician to turn the ignition switch to the lock position and then back to the on position, or alternatively, press the engine start-stop button to switch from off mode to on mode. This action powers up the vehicle's electrical systems, allowing the onboard diagnostic systems to run or refresh. The purpose of this step is to ensure that all modules are properly energized and ready for communication. Power cycling is a standard practice in diagnostics, as it often resolves transient issues and establishes a proper baseline for following tests. It is essential for the technician to follow this process to ensure that all subsequent checks are performed on a correctly initialized vehicle system. In this step, the technician is instructed to turn the power sliding door main switch on. This action activates the main control circuit for the power sliding doors, allowing testing of the door's functional systems. The main switch controls the operation of the sliding doors, and ensuring it is in the on position is crucial for the upcoming diagnostics. By activating this switch, the technician prepares the system for functionality checks and enables the electronic systems to respond to command inputs. This step serves as a critical pre-step in ensuring that all functions are ready to be tested effectively. It is fundamental for appropriate diagnostics to confirm whether the error code B2029 can be replicated, or if it appears only during specific operational conditions. The fourth step in the troubleshooting process is to check for DTCs again, using the HDS after the previous steps. This step is pivotal, as it determines if the DTC B2029 is still present or has cleared after performing the initial tests. If the code remains, it indicates a persistent issue needing further investigation. Conversely, if the code is not present, it may imply an intermittent fault or connection issue. Understanding the distinction between persistent and intermittent codes is crucial, as it guides technicians on what to focus their efforts on in subsequent diagnostics. This reiteration of checking DTCs not only confirms findings, but also validates the steps taken thus far. In this troubleshooting step, the technician should turn the ignition switch to the lock position, or utilize the engine start-stop button to select the off mode once again. This action serves as a reset of the systems involved. By cycling the ignition, the technician ensures that any residual faults or temporary glitches are cleared before proceeding with more in-depth diagnostics. Resetting the system prepares the control modules for new tests and helps avoid confusion from previous error states. Having a reset state is essential to troubleshoot efficiently and to provide a clear diagnostic pathway as the technician moves forward in examining the wiring and connections relevant to the left power sliding door remote control assembly. Next, the technician needs to disconnect the left power sliding door control unit by removing both connector A, 12P, and connector B, 16P. This step is crucial for isolating the control unit from the circuitry, allowing for independent testing of its components. Inspection of the connectors themselves is vital to ensure they are not damaged or corroded, as this can lead to poor electrical connections. The disconnection will facilitate continuity testing, where the technician can check for proper electrical pathways. Understanding the specifics of this step is important for diagnosing whether the control unit itself is functioning properly, or if the wiring has a fault. This procedure is critical in narrowing down the type of failure present in the system. The seventh troubleshooting step involves disconnecting the left power sliding door remote control assembly from the vehicle's electrical system. Specifically, the technician must remove connector A, 14P. This action allows for troubleshooting to be focused on the control assembly without interference from other components. Disconnecting this assembly is essential for isolating potential faults within the remote control switch itself. As with the previous steps, technicians should ensure the connectors are clean and free of damage. A thorough inspection during disconnection can prevent further issues down the line and helps identify whether the problem lies within the assembly or elsewhere in the circuit. This step sets the foundation for performing continuity tests that can confirm the health of individual components. At this stage, the technician must check for continuity between the left power sliding door, remote control assembly connector A, 14P, terminal number 12, and the body ground. Continuity testing is a crucial aspect of electrical diagnostics as it assesses whether there is a complete circuit, allowing current to flow freely. A successful test indicates that the electrical pathway is intact, while a failure suggests there may be a short circuit to ground within the wiring. This step helps to identify if the wiring connected to the remote control assembly is functioning correctly. If continuity is confirmed, the issue may lie within the remote control switch or the control unit itself. On the other hand, a lack of continuity will require pursuing repair to address any grounding or wiring issues. This troubleshooting step requires the technician to lock the child-proof switch and then operate the inside handle to the open side for at least 3 seconds. This action aims to verify whether the sliding door can still be operated via manual input, even if the electronic system encounters a fault. Locking the child-proof switch is crucial, as it prevents the door from being opened unintentionally while conducting tests. Activation via the inside handle can help to rule out whether the door mechanism is mechanically jammed or if the problem is strictly electrical. Conducting this check is invaluable. It allows technicians to determine if the door can still function correctly, offering hints toward the underlying issues at play. After this operation, technicians will evaluate the DTCs once more for further diagnostics. In this step, the technician must once more check for diagnostic trouble codes with the HDS after operating the inside door handle. Retrieving the codes again serves to confirm if DTC B2029 has reappeared following the manual test. The presence of the error code after this procedure may indicate a persistent failure in the circuitry or control unit associated with the remote control assembly. Conversely, if the code is not present, it could suggest an intermittent failure, possibly caused by poor connections or transient faults that require further attention. This repetitive checking is essential for establishing a reliable diagnosis, allowing the technician to zero in on where the potential issues lie. Understanding the difference between persistent and intermittent errors is critical for effectively addressing and resolving the concerns with the sliding door mechanism. In this next step of troubleshooting, the technician needs to turn the ignition switch to the lock position or again use the engine's start-stop button to select the off mode. This action is important as it ensures that the vehicle systems are powered down fully before executing any further diagnostic check procedures. Powering down the systems can help with eliminating any residual charges or pesky glitches that may affect continuity testing or other diagnostics in later steps. It prepares the technician for a clean start in the next procedures, contributing to a more reliable diagnostic process. As with previous steps, ensuring the vehicle is powered down serves to protect both the technician and the vehicle's electronic systems while further assessments are made. The 12th troubleshooting step involves disconnecting the left power sliding door control unit by removing both connector A, 12P, and connector B, 16P. This procedure is critical to isolate any potential failure points within the control unit itself, especially after performing various functionality checks. Disconnecting allows for a thorough inspection and testing of the unit and the related connections. This gives technicians a chance to examine any wiring impacts, ensuring there are no physical damages, corrosion, or loose connections obstructing proper operation. By taking this methodical approach, professionals can gather more accurate data, building a clearer picture of where issues are actually occurring within the electronic systems governing the sliding door functions. This isolation is key to understanding how to effectively repair and restore functionality to the system. In the 13th step, the technician is tasked with disconnecting the left power sliding door remote control assembly connector A, 14P. This action mirrors previous steps of isolating components for a detailed inspection. By focusing on the remote control assembly, technicians can pinpoint if the issue originates within this specific part of the system or if it lies deeper within the control unit or wiring. It's important to check the electrical terminals of this assembly upon disconnection for any signs of wear, corrosion, or damage that could impede functionality. Thorough assessments of these connectors allow for quick identification of any manufacturing defects or wear-related failures, crucial for ensuring the integrity of the sliding door system. This step focuses on laying the groundwork for effective continuity and troubleshooting tests going forward. In the final troubleshooting step, it's essential to check for continuity between the left power sliding door remote control assembly connector A, 14P, terminal number 9, which plays a significant role within the system's function. By conducting this test, the technician can verify if there is a proper pathway for electrical current to travel from the connector to the control unit and ultimately to the door mechanism. Ensuring continuity at this step confirms that the wiring is intact. If continuity is confirmed, it is likely that issues may reside within other components, like the control unit or the remote control assembly itself. However, if continuity is absent, further investigation of the wiring must be undertaken, looking for shorts, breaks, or corrosion that could impede function. This thorough check is essential for comprehensive diagnostics to restore reliable operation to the sliding door systems in the Honda Odyssey model. After completing all the necessary troubleshooting and corrective measures for DTC B2029, it's critical to conduct a final verification of the repairs. This verification ensures that all issues have been addressed effectively and that the left power sliding door functions as intended. The technician should recheck for any diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS, to confirm that the B2029 code has been resolved and that no new codes are present. Additionally, it's vital to perform functional tests on the sliding door using both the remote switch and the inside handle to ensure that full operational capability is restored. This final step not only verifies the effectiveness of the repair, but also assures the vehicle owner that their system is reliable and functional moving forward. This completion check contributes to overall customer satisfaction, ensuring a dependable vehicle. Preventive maintenance is essential to keep issues like DTC B2029 at bay. Regular inspections of the wiring connected to the power sliding door is crucial, as the protective insulation can wear over time, leading to shorts or exposed connections. It's advisable to routinely test the control switch to ensure that it operates correctly, preventing any future malfunctions. Additionally, Maintaining clean connectors is vital, as corrosion can impede effective electrical connectivity. By incorporating simple routine checks into the owner's maintenance schedule, one can significantly decrease the likelihood of encountering issues in the sliding door system. Preventive maintenance not only extends the life of vehicle systems, but also enhances overall reliability, ensuring that the Honda Odyssey remains safe and convenient for daily use. In conclusion, addressing DTC B2029 on the Honda Odyssey requires a systematic troubleshooting approach. It's vital to understand the roles of each component involved, particularly the left power sliding door remote control switch and associated control units. Identifying possible causes and symptoms is the first step in a comprehensive diagnostic process. Effective troubleshooting not only resolves the current issue, but also points toward preventive measures that can save time and expenses in the long run. By applying preventive maintenance strategies, vehicle owners can maintain their sliding door systems in good working order and enhance overall safety and functionality. This thorough understanding empowers technicians and owners alike, promoting long-term satisfaction with the Honda Odyssey. Please like and subscribe to the channel. See you next time.